Hi there guys, welcome back to the shop. I'm Chris Boden and today is a glorious day in my manly life. I officially got another punch on my man card. I have bought my very first welder. Now, I've never even turned it on, but I watched the 22-minute long DVD on it, so I am officially a YouTube certified master welder, and I'm probably 5 minutes away from getting a job doing underwater aerospace welding of Inconel, I think is what I'm gonna shoot for. But before I can do that, I've gotta be able to plug it in. And this is a thing that, while I don't know anything about welding, I know a lot about plugs. And this is the plug that came with it, and I just like, no, this is, like, yeah, big, chunky, okay, cool, but we can do better. And I already have a big serious extension cord for job site use and stuff like that. And this is almost specifically for working on the boat, at least in this stage of its existence. So I can't use this plug. And this is a really common problem that I've seen a lot of guys have with new welder is you got to put a different plug on it. And while you guys probably know a hell of a lot more about welding than I do, which is why I started out simple with just a little hot glue gun for welding, I figured I'd take a minute and help you get set up with a new plug. So let's do that. I have a sexy new plug and a substantial upgrade that we're gonna put on here, and we're gonna talk about why I'm changing the plug and why you might want to as well. And this is totally a thing you can do. It's super easy, so let's get into it. All right, so before we even get started, I'm gonna grab my electrician's hammer here, and we're just gonna do the best thing you can with this kind of plug, and that's just, there you go. I feel way better now. And you'll notice I cut that tight. I don't ever intend on reusing this. I don't ever intend on using this. That's, so inside, right off the hop, you can see we've got 3 wires. We've got a green, black, and a white, which is cool. It's a Lincoln, and they wired it with an American plug. European plugs will have different colors. So the very first thing I'm gonna do is strip this off. Now, the technique for doing this is not hard, but it's easy to screw up. There's about 5 million different ways to strip a wire. This is probably just an SJ cord. Yeah, SJT. So the easy way to strip this, in my experience, is get a very sharp utility knife. You can do this with an X-Acto blade too. We don't need to strip a lot, so I'm just gonna take about 4 inches off the end and bend it over really tight. And then just gently, don't do that. Because what you want to do is you want to cut the outer insulation without cutting the inside insulation, because the 3 wires inside are individually insulated, and then the whole thing is wrapped in this black heavy plastic stuff, and that's how you get a Service Junior cable. That's why they call it SJ, it's Service Junior. So we're going to fold that over like that really tight, and we're putting a lot of stress on the cable, which is something you very rarely do. Like, don't do this with Ethernet. And then we're going to take our blade and just roll it along the outside, and I'm just barely pushing, just enough to leave a line. So we're going to do that, and that's going to give us a line. And because we're putting the cable under so much stress, that line is going to turn white. You'll start to see just a little hint of white down inside there. And when you've just barely got that white line, we're gonna roll over to a different spot. I'm gonna rotate the wire about 90 degrees, keeping my spot up at the top still, and then bend that over there. And then I'm gonna do the same technique for another 90 degrees of the wire. And I'm just pressing. You're not sawing at it or any of that. And it's okay if the line doesn't perfectly line up. This is not by any means the fastest way to do this, but it's the safest, because what we don't want to do is screw it up and have to, because the worst case is you just screw it up, nick your wires, and then have to roll on up like another 4 inches and start over again. And you're just gonna work at this and take your time. And if you see any little bits up at the top where it's still connected with like a thin little wisp, break that apart and just cut at them. So when you get all the way around, it's probably not gonna line up, and that's fine. Like you can see here, I've got 2 different spots. We're up here and down here, but you can see how it splits open. You can see the wire inside, and you wanna not cut that inside wire. So we don't line up, and that's fine. You just connect the 2 points with just the lightest of pressure. And when you get all the way around, the last remaining little bits will just pop. When they get thin enough, they pop, and if they're not thin enough yet, then you just kiss it with a razor blade, which is the title of my punk album. So that one there isn't, oh, it's so close, but it's just that last little bit. You can see it's broken all the way around. So when it gets to this point, you can probably just yank it like that. And now you've got your wire stripped, and the big thing here is that none of the inner conductor is nicked. And if you're gonna nick it, it's gonna happen right at the edges here. So if you pull that back and you see any shiny copper at all, you got a problem. Now this is way more than we need to strip, but I like to have a little bit extra work with. And you can see this white powder in here. You can just wipe that off. That's just part of the internal construction of the cable. All right, so we've got our wires stripped, and the first thing I notice is those wires are really tiny. Like that's like 14, 16 gauge, where are we at? What do we got here? Oh, hey, look at that. 3 by 14 American wire gauge. So the thing is, now it's different in conduit with THHN versus, yeah, okay, fine. But the back of this thing says this is rated for 20 amps, and they put a 20 amp 240 volt plug on it. That's a weedly ass little wire. That's really tiny. Will it work for this? Sure, it will probably work, because that's a weedly ass little tiny beginner welder. This is not a for serious welder. This is a beginner welder. It's not a toy, but it's a toy, okay? I'm certain this will work fine for this welder because the welder draws 20 amps, and because Lincoln's been making welders since way longer than I've been alive, and they're not going to put a cable on there that's instantly going to melt down because that would cost them money. But do I absolutely believe this is the minimum viable possible cable you can power this off of? Absolutely. Do not, because you're gonna run this off an extension cord. A lot of people run welders off extension cords because that's just the nature of the work. I've got a 30-foot boat, I'm gonna have a 50-foot extension cord. Don't run that off a cheap, like 14 gauge extension cord, because it's not going to work. You're gonna have problems that can end in like building on fire. So just don't do that. What I'm doing is I have a 50-foot long extension cord that's made of 10 gauge, so it's quite happy to run all day at 30 amps. And I'm upgrading the plug on here from a 20 amp plug to a 30 amp plug. And you can see the plug here is a totally different type. Like they look completely different. And it's an L14-30P for plug. And this is first off, we've got an extra conductor happening here, and what the hell. But the big thing with this is if you look at the plug on the end, see that little hook off to the right? And there's a hook off to the right, and there's a hook off to the right, and there's a hook off to the right. All the way around, they hook to the right. And the reason is, when you plug this in, you go chunk, and it locks. It won't yank out of the wall. And the extension cord that this will plug into, at the end of that, chunk, lock, and it's cool. So you can drag this around, you can pick up the welder, move to the other end of the boat, and just drag the cord along, and it's not gonna pull the cord out, which is super useful. Locking plugs are awesome, and I recommend them for anything that vibrates, like an air compressor, where you usually have a very short plug and they don't move around a lot. Like I'm talking like big chunky air compressor. Okay, it sits on its happy little pallet and it doesn't move around a lot, but it moves constantly because they, so locking plugs are great for that kind of thing. Something like this will wiggle out of the wall eventually. So we got to install our plug. Let's take a look at how. I'm actually bringing out the instructions because this is an instructional video. So look here, inside, when you get the plug, okay, and it comes in this little thing, it comes like this. And the instructions are just a single little card in the back. It's not hard, but for non-electricians, it might not be particularly obvious. So let's look at this and see what we get. The first thing we see is 1.5 inches for here. Okay, that symbol, let me get a pointy thing. Like a pencil. This symbol up here, the line with a number in the middle, like 1.5 inches, that means that the distance from there to there is 1.5 inches. Ish. It actually means really pretty exact, depending on how many things are after that. But that gets into engineering 101, and we're not going to be doing GD&T today. So over here, the second picture, you can see the measurement is from there to there, and that's our conductor. So this is the insulator, and this is the conductor. And that tells you how short you want your wires to be and how much you want to have stripped off. This is a part where you need to pay close attention because I've seen people do this more times than I care to count. If you look at the picture, I see guys frequently will hold the wire up here and be like, all right, that's what I need. It's not. See how the picture says 1.5 inches? Okay. They mean 1.5 inches of the insulator, not the whole thing. The whole thing, you need 1.5 inches of insulator plus 5/8 of conductor. If you measure the picture, it's 1 inch. If you measure the picture over here, okay, are you with me so far? Is not quite. The picture is not full size, so you have to actually measure the damn wire. This is important. So we're gonna do it by the book. We're gonna absolutely do this perfectly. So what I'm gonna do is open it up. I can just leave that right on there, can I? Yeah, that's fine for that. Is that small enough? Ooh, it's really tiny. Do I want to flip that around? I might. I'm gonna check this and be sure so that you can be sure, because you may be doing this on the exact same welder. We measure off 1.5 inches. Now you can see my squares here are 1 inch. So we'll just go there and 1/2. Okay, now we know we need 1.5 inches of jacket, and then we know we need another 5/8 of conductor. So we've got 1.5 inches of jacket, and then we go out, there's 1/2 and 1/8 and a little hair. Don't add too much extra because it won't fit in the damn thing. So we'll cut it off and see where we're at. 1.5 inches plus 5, that's actually pretty close. Okay, I can live with that. All right, so this seems really long, but that's the 1.5 inches plus the extra 5/8. So now we're gonna strip off about 5/8 off the end. I have my festive Nipex. These are awesome and I love them. So we're gonna pull this back. That's a little short. So we'll adjust these back for about 5/8. Oh, that's lovely, okay. And we'll just pop that right off. And there's our 5/8. I'm gonna twist this down tight. And I'll show you the difference because this is important if you're not accustomed to doing plugs. Okay. When you first strip it off, it's gonna look like that. And see how they've got a slight twist to them? That's just the natural lay of the cable. And this one I twisted and they're super tight. You wanna do that because if you don't, when you put this into the plug, there's going to be a little hole in the back of the plug. Some of the wires will pop off to the side like that. And that's called a flyer. And those can be bad. Just, you don't want to have that, because the best case scenario is it's not doing anything. It's not doing its job. We've only got 14 gauge cable. You need every single wire you can get. But the worst case scenario is that little wire goes off and touches something else, and that's really bad. That's not going to happen in a quality plug like this, because it's all individually shielded. So drop this up your cable and just forget about it for now. We'll get back to that. But it's a practice you don't want to get into. Now on our plug here, when you look at the back, you can see one of these is green, and they even give them little letter designators too. There's a little G there, and that's the green plug. This is the ground connection, and it goes to the green wire. So we're gonna connect that one first. I always do ground first just because habit, safety, best practices. So as you look inside there, let's talk about how this works a minute. When you turn this screw out here, it's gonna move a little clamp inside. See a little clamp move? So you wanna make sure all of your clamps are open all the way. When you first buy the plug, they're going to come mostly open, but just unscrew them all the way. Don't force this. You're just fingertip pressure. It's super gentle. And then have these pointing down, okay? And then this goes in the top, and you just slip it right in there, and it'll bottom out, and it should, if you stripped it right, and we did, you can see through the clear plastic. You want to make sure that you're clamping down. I don't know if I can show this on camera, but I'll try. It's hard to see, but you can kind of see it. You can see the clamp inside there, and you can see the shiny conductor. You want to clamp down on the shiny conductor, and don't run the clamp down on the insulator. That's a really important thing. You want to clamp only conductor, not insulator. Because if you run the clamp down on the insulator, it's not going to work. And we're back to diminishing capacity. So once you get it down, just with like light finger tight, then come in a little bit harder and check it and look at it and make really sure and have everything right, because you don't want to do this twice. Then hold this and run that down tight. Okay, so that's how you do a connection. Tug it, it's on there, this is good. So let's look at the other ones. We'll notice there's color differences. We have our green for ground, we sorted that out. Then we have a brass connection. See how the screw is like a golden color? And then we've got a shiny chrome one, and then we've got another brass one. Now in this instance, because we're hooking up a 240 volt plug, this is very different if it's 120 volts. With a 240 volt plug, because these are our colors, and we know that both of those are hot, both of these go to a brass connection. It doesn't matter which. You can flip them around and it's not gonna care. But we run our wire in, we've got a brass thing here, that means hot, okay? And normally in the world of electrical work, in America, black to brass is how you remember that, black to brass. And that's your hot connection. Now this is 240, so both of them are hot. Normally, with 120 volt stuff, with like if you're just putting a regular plug on a regular thing and it's not 240 volts, the white wire goes to the silver one. But this is one of the very rare instances where we've got our black to brass, our green to ground, and the white one's gonna go to the other brass one. And this is a thing that a lot of people can easily screw up, because if you don't know, if you're just used to, if you read a thing online or something, almost everything's gonna tell you that the white goes to a shiny silver one. Because that's how your house is wired. That's how every outlet in your house is wired, except for the 240 ones. And the reason is cheap. They could have got cable that had 2 black wires and a green. They absolutely can, they sell it. And you can even get black, red, and green. But they didn't. This is much more common because this is what most power leads are, is the black, green, white. So it's easy to make that mistake. It's easy to send confusing and conflicting color signals to people, and it's just, this is not a place for mixed messages. So I'm gonna grab a different screwdriver because I wanna get these super tight, and Phillips head is not the weapon of choice for maximum tightness on a screw. Okay, so those are down. We're gonna tug test each one. Give them a good yank. Can you pull it out? Nope, it's good. All right. Now, the trade-off is this plug is designed for 30 amps. This plug is expecting 10 gauge cable. It's expecting big, heavy, rawr. This is a wheedly ass little, it's shit. It's a shit cable. So what we're gonna do is there's a key here. You can see that your cap is keyed, and there's a notch here. You can see. Put the key in the notch, and that's where it's gonna line up. Now we're not gonna screw it down yet because I just wanna get a look at where we're gonna be. So we can see this lines up just perfectly. We're gonna stuff that in just a bit, but this is our spot. Now the problem we have is that if I put this on here, it's not gonna clamp down enough to hold the cable. And you need it to. You can't just let the cable flop around in there, because instead of the stress being put on the jacket of the cable where you want it, because the jacket of the cable, very, like I could hang from this and be fine. It's not gonna damage the cable. But if you have the plug on there and you're putting all that force like this and it's just going right through the thing, then you're putting all that force on this little connection in here, and those will yank out. And that would be bad. Now it's not super dangerous as long as you like trip over this and yank all three out at once. But if you just yank one out, well, now your machine isn't grounded, or you're only getting half the power and things catch on fire, or bad things happen. So we need to get that strain on the jacket of the cable and not the plug. So this is where we get to use some jank, half-assed engineering, but it really is the best way to do it. My very good friend, 3M Scotch electrical tape. This is the good stuff. Get the good stuff. Don't buy cheap electrical tape. It's just bad. So what I'm gonna do is put a big old gob of electrical tape around right here at the end where I want that to grab, because there's a clamp built into the housing. But before we can get into that clamp, we gotta make our cable larger in diameter. So I'm just gonna, and I am not doing like a proper wrap with the tension and the proper amount of squeeze in it. I don't need to, because I want this to be big and chunky. I am building a strain relief clamp from just some tape, because you can do that. We're just gonna put a big old wad of tape on here, and yeah, I'm gonna taper it down a little bit. But what I want is a big chunky piece. Oh, we're getting up to about 1/2 inch thick there. That should be all right. Let's take a look and see where we're at. That looks about right. Yeah, that'll do. All right, so you'll notice I haven't screwed this in yet. I'm not going to, not yet. So we're gonna line up our tape, and that's just a big wad of tape right at the end of the wire. Okay, and then I'm gonna get my clamp, and this is all part of the plug, and you can see there's a couple holes there. There's a couple holes here. Line this up. And then we're gonna tighten this down. And do one a little bit, and then do the other a little bit. And then go back and walk it back and forth. Now when you're tightening yours down, before you do it, make sure that you're lined up. This doesn't have to be fully engaged, but make sure that you are lined up at the right spot for the key to fit in the thing, because you're in tight enough that it may not spin, because there's keys and stuff on the inside. There's features. So we'll just run this all the way down. And you don't have to get stupid tight with this. It's designed very well and it will take it. So you can see the end there. That is, I've got a big crush area. Is it pretty? No. Will it work? Work just fine. It'll work very happily for the next 30 years. So now we push this down and make sure we're all lined up, and it'll only go in one spot, so the key is going to be engaged properly. Like if you can get it down this far, you're cool. And then we just run these 2 screws down. And the screws are kind of weird, and this is on a lot of plugs. The screws, this screw on a plug, watch how much that turns versus how fast it goes in. Shoomp. Okay, like 1 turn and it's in. The thread pitch on plug screws is always really crazy high, and I don't know why, and I just think that's neat. But we're done. We built a plug. Okay, it's on there, it's terminated, it's good, it's simple. There's nothing to this. You can do this, you can make this happen. It's not rocket science. And people that are way dumber than you do this every day and it works just fine. Don't be afraid to modify your gear, because now what I've done is I've put a big chunky plug on here that I can put in and give a twist lock to. I know that this will interface perfectly with my 50-foot-long extension cord that is way properly beefier wire, and this plug's gonna live longer than this welder is. Like realistically, unless I run over this with a forklift or something, this plug will outlive the welder. And that's how you change a plug on your welder. It's not hard. You can do this stuff. You're capable. Just takes the time. Do it right. Have the right tools. Have the right bits. This is already kind of jank. Don't get stupid with it. Take your time. Do it right. You're going to be fine. Don't be afraid to learn new stuff and try new things. You guys have fun. I'm Chris Boden, and as always, I'll see you next time. That is not my best video. That's not even my best video of changing a fucking plug. But it'll do. Cause the cable is shit. 14 gauge cable? Oh. That cable's rated for 15 amps and I just put a 30 amp plug on it. But it works the other way, not this way. And I'm gonna catch hell about that. There's gonna be people coming, you just put a 30 amp plug on a 15 amp cable. You're an idiot. Well, the circuit breaker's on that fucking end, isn't it? Circuit breaker's up here. It's right. It's a button on the back. And that is control from the load end. Not the line end, the load end. It's fine. There. This has a totally different thing on it. It's gonna be fine. It's gonna be fine. because this determines where that is, and it's okay. This says this is designed to handle that, and it's good. And I can put a 500 amp service on the ass end of this, as long as I'm protected with the proper fuses and breakers in the proper locations. It's okay.